is Sarim Khan, and today we are back to laws of motion. And since this video is the part 2nd of laws of motion, we have already covered the part 1st of laws of motion, in which we have already discussed many things such as equilibrium, forces and many those kinds of things. But today we are back with part 2nd of laws of motion, and in this first of all we'll discuss over the Newton's laws of motion and whichever terms will be required to study Newton's laws of motion, such as momentum and inertia. So those things we'll discuss, and along with that we'll also discuss to the Lami's theorem. Then let's begin today's topic. So first of all we'll start from Newton's laws of motion. Since laws of motion are since we know that there are 3 kinds of laws of motion given by Sir Isaac Newton, the great scientist. So first of all, since earlier what would happen, Aristotle would say such that if we have any ball and the ball is rolling over the ground, so what will happen, we have to continue to apply external effort over the ball so that it will continue its motion. This was believed by Aristotle, but later Galileo Galilei came into arena, and Galileo Galilei said such that no, we do not require to continue to apply external effort over the ball. The ball will continue to move, it will continue to move. But imagine, it will be possible only in such a world in which there would be no frictional force, because here we can see, here we are talking about no friction, just like Aristotle would say such. If there is no force applied over any ball, then it will continue to be its own state. So here Galileo Galilei says, but friction opposes the motion. So if friction is not, then it will continue to stay in the state of motion or rest. If it is at rest, so we have to apply external effort, then it will come in motion. If it is moving with uniform velocity, so we do not require to apply any external effort, then it will be continuing to move with uniform velocity. And if we are applying any external effort, so it will be accelerated. Any external, suppose I am pulling that, so of course it will decelerate or retard. But if I am just pushing that more, if it is going in this direction and in this direction I am applying force, so it will just accelerate and its velocity will change. And how it will change? Velocity will increase, because final velocity here will be the greater than initial velocity. So this is said by Galileo Galilei. Later what happened, that Sir Isaac Newton came and he stated this in a simpler manner and said that this is known as the first law of motion. Since we have already discussed the first law of motion, then what first law of motion states that if we have, suppose if we have any particle, this first law of motion main statement is this, that any particle will continue to stay in the state of rest or motion unless any external force is not applied over the particle. This is the main statement. If we want example, so we can write here in this case. Suppose we have any ball, after that what I say, it is kept over the surface. Suppose, and the friction in the surface is 0. Suppose the coefficient of friction of the surface is 0, then since we know that friction is equals to what? Frictional forces mu n, and if such happens that mu value is 0, means the coefficient of the friction of the surface is 0, so which is equals to 0n, which is equals to 0 means the total frictional force will be also 0, so there will act no frictional force, means there will be no force present to oppose the motion and it will continue. So according to first law of motion, if it is moving here with velocity v, so when it will come here, then also it will move with velocity v if we are not applying any external force. But imagine, same case I have. What happens here, I have any velocity u kept over the surface. Again ball is kept over surface. It is also smooth. Suppose the surface is smooth. Since we know what is the meaning, physical meaning of smooth, if we talk in physics, it means the surface is frictionless. There is no friction on the surface. And according to this, if we are going, then when the ball will reach here, suppose I am applying any external force from here, F, in this direction. When ball will reach here, its velocity is v. So of course, This may be possible that v is greater than u. This may be possible. Of course it may be possible, because here I am accelerating. Whenever there is a force, there is an acceleration, because whenever any object is at rest, any particle, and when we apply force over that, so force produces acceleration, and acceleration produces what? It produces a change in velocity, because acceleration itself is what? Acceleration itself is the rate of change of velocity. So according to this, acceleration is what? It is that cause due to which velocity is changed. It is that because of acceleration always velocity gets changed. So force produces acceleration, and acceleration produces the change in velocity. So according to this, the particle is accelerated. Means according to this, here any force is applied, because whenever there is a force, there is an acceleration. So this is the first law of motion. Now the question arises, why it is such? Because of course there should be some answer of this why, and if first law of motion doesn't have any proof over this, so by this we can get that the first law of motion then will be wrong. But is it wrong then? Of course it has answer to it, and the answer is all because of inertia. We talk in physics about it as inertia. Okay, so now question arises, what is inertia? Inertia, if we try to define, then inertia we can define as it is a property, or it is a tendency for any particle to oppose any change in its state of rest, motion or direction. It means, suppose example we are taking, I am taking any example. Okay, so here after taking example, suppose I have any ball kept over the surface. Later what happens? Later I keep the ball like this. Okay, I do not do anything to the ball. I am seeing that from any kind of frame of reference, from any reference point, that the ball is at rest. Suppose. Then what I can say? Why is it at rest? Because of inertia. Because the ball has a special property, so that it will try to oppose every kind of change in its direction, rest or motion. Because already the ball is at rest. And if I am not applying any external force, so it will continue to be at rest. If I am applying, so suddenly it will come in motion, because it will be accelerated. So velocity will change from 0 to something. It may be v, or it may be u, anything velocity may be. But here we can see that the ball will have some property that will help the ball to stay in rest. And later what happens? Suppose that the same ball, I give it velocity v, and after giving velocity v, I leave the ball. So later what will happen in this case? It will continue to move with velocity v if here mu equals to 0. Because if mu equals to 0 means frictional force is 0, means the total which surface is that is totally smooth, or that is totally frictionless. Then it will continue to move with the same velocity v. Okay, so according to this, then it will have also inertia, because now the inertia, earlier inertia was trying to stop all the forces to bring it in motion, but as it came in motion, it is trying to stop it to change its direction or to change its state of motion to the rest. So this is known as the inertia. But if we talk about kinds of inertia, so inertia generally we write in 3 kinds. First is inertia of rest. Okay, first is inertia of rest, then is inertia of motion. Okay, then is inertia of motion, and final kind of inertia we have as inertia of direction. Okay, means there are in total 3 kinds of inertia: inertia of rest, inertia of motion and inertia of direction. So according to this, if we have to define all those 3 inertias, so inertia of rest we can define as, inertia of rest is that property of any particle that helps itself to maintain itself in the state of rest. Suppose I have any block, same particle I have, when I had kept it at motion, so it continued to stay in motion. It was opposing every change, okay, in its state. So that is is because of its inertia of rest. Inertia of motion, it opposes any change in motion, in a state of motion, and direction, it opposes any change in the direction. Since if any particle is going like this, if frictional force is not, means the coefficient of friction is 0 between the ball and the surface, any particle, then what will happen? It will continue to go in the same direction, and we are not applying any external force. It will continue to go in the same direction. It means there is some inertia of direction in an object. So any object has inertia of rest, motion and direction. This is known as the inertia. So since already inertia we have studied, the first law of motion statement we studied, why is it possible we have studied. Now let's begin our second law of motion. Let's move to it. So first of all, let me rub the board. Okay, now let's move to the second law of motion. Second law of motion. So first of all, what second law of motion predicts? It predicts that F is equals to ma, means the force is equals to mass times acceleration. Since force is a vector quantity, acceleration is a vector quantity, while mass is a scalar quantity. So on force I have put arrow, on acceleration I have put arrow, but on mass there is no arrow. So here we can see this is the second law of motion, or we can write according to this formula, or acceleration is equals to force divided by mass. This we can have, of course, but how is it possible? Okay, question arises that why is it such? So if we try to reply this question, so we can say that there is a very famous statement called about F is proportional to the PF minus PI divided by T. Now question arises, what is P? Okay, what is actually P? So here P is called the momentum. What is momentum? So we have to define it. First of all, before defining it, this is the main statement of the second law of motion. Generally this you may read, but actually which is the main second law of motion? This is called the true second law of motion. Okay, now but from this we can gain this formula, we can easily derive this formula. But before that we need to know what is actually P. So, or momentum. So momentum, if I write as P, it is generally represented as P. This is known as the product of mass and velocity. Since momentum is a vector quantity which is the product of mass and velocity of any particle. Suppose any particle I have moving in any certain direction. Okay, later what happens that if I have to calculate its momentum. So if the mass of the particle is m and its velocity in any direction is v, then I say that the momentum of the particle is the product of mass and velocity, means mv. So I can write T equals to mv. So since this is very simple, if we know about momentum, we can easily from this formula derive this formula. How? So we can easily do it, because suppose I am giving you example. If any particle I have, what happens that its mass is m, later at t equals to 0 its velocity is u, and suddenly at t equals to t its velocity becomes v. So for this particle there will be two momentum of the particle, because there are two velocities of particle. First will be final momentum, second initial momentum. So PF, okay, since here is final, here is initial. So PF, how can I write? I can write it as, okay, mv. Of course, I can represent it as mv because final velocity is v. Okay, I can do it. While pi, if I have to write, so mass into initial velocity means u. So pi is equals to mu. Now, since if we go according to this formula, means the force is proportional to the rate of change of momentum. All the change of momentum divided by the time in how much so much momentum is changed. So if I go according to this formula, then I can write F is equals to proportional, no, okay, F is proportional to the PF minus PI by T. So PF value I have mv, PI value I have mu. Can I put the values? And if I put, I will get mv minus mu by T. This I will be getting. And if I go according to this formula, so what I can write that F is proportional to the, and mass common I will take, and bracket v minus u, bracket close, divided by what? Divided by t. And if I see, since we know in kinematics what we learned, that A equals to v minus u divided by t. How? Because since v equals to u plus at, then A equals to v minus u divided by t. First equation of motion, from this we can gain. Then here what we can see, according to this, here is also v minus u divided by t. So if at the place of v minus u divided by t, I write A, so there will be no changes. Then let's try to write here A, implies that the f is proportional to the m. Since there will be no changes in m, only this value I have changed, v minus u by t. Actually there is no change, only here shorter I have done. So f is proportional to the ma. But here proportionality symbol is, and here we have to bring equality symbol. So for that we'll have to remove the proportionality constant, implies that the f is equals to what? Proportionality constant will fall. So f is equals to kma. This we got, but here is again f equals to ma, and here is f equals to kma. So only what we have to do is that suppose the particle, okay, there is any force on the particle, any force acts, and that is 1 Newton. After that what is, suppose mass of the particle is 1 kg and acceleration, the force accelerates to the particle by 1 meter per second square. So according to this, if I write, so 1 Newton is equals to what? K into 1 kg into what? 1 meter per second square. This will be, from here what is the value of k? Implies that the k equals to what? K equals to 1. Since proportionality constant it is, so k equals to 1. This we got, and already proportionality constant means it has no unit. Here it has no unit, only its value is 1. So according to this, if we are going, we are putting, then f is equals to what? If 1 into ma means 1 ma, which is equals to what? ma, implies that the f is equals to what? ma. So this is our known as the second law of motion. Finally we have derived the second law of motion. This is known as, okay, second law, Newton's second law. So since mainly this is known as Newton's second law, but sometimes this formula we can apply, but mainly if I tell you means main formula of the second law of motion. So this is the 100% true correct formula of the Newton's second law of motion. This is the correct one, second law of motion. While this we have derived from this formula, but which actual formula is that? Will be f proportional pf minus pi divided by t, or the force over any particle is directly proportional to the rate of change of momentum of particle. So first of all let me rub this, after that we'll be solving next. Okay, now we'll move to our next law of motion, that is the third law of motion and the final law of motion. So if we want to study the third law, or Newton's third law of motion, or you can simply just call it third law of motion. So since it already predicts about the action reaction pairs of forces, okay, what are those? So actually we can call, suppose I am giving you example, if I am pushing this board with any certain force F, so the board is also pushing to me with certain force F, okay, means both magnitude are same, only what will happen, that the direction of both forces will be opposite. Example I am giving to you, suppose that here any object is present and I apply any force F on the object. So what will happen, that the object will also press me with the same force F, will push me with the same force F, only what difference will come, that the direction of both forces will be opposite. If suppose that I am making, this is the particle, I am pushing it with F, then the particle will also push me with F, only what difference is, that here since we know here is F and here is F, so the angle between F and F is 180 degree, means the two forces, action reaction forces, actually those are called the action reaction pairs of forces. So the two forces we can call that they will be in just opposite direction to each other. This is known as the Newton's third law of motion. If we are pressing over any wall, then the wall will also press to us with the same force, but the direction of both forces will be opposite. If we want, then we can also call, we can expand the Newton's third law of motion by saying that in all cases it is not possible. Since example, let us take, suppose I am putting any block over the surface. Then there is, suppose that the mass of the block is m. So what will happen? Down will be the weight of the block. Down will be the weight of the block, which is mg. W equals to m into g. So according to this, since we know there will be some value of g, suppose it is put over the surface, and on the surface of the earth g equals to 9.8 meter per second square, and sometime just like maybe in some problems it becomes very complex, so we take 10 meter per second square. So W means weight of this block is mg. Then upward, since we know upward one force is acting, that is normal force. Normal force magnitude is also mg, just in upward direction, perpendicular to the surface of contact. This is the surface of contact, perpendicular to this. Always it acts to the perpendicular of surface of contact, means n is equals to mg towards the y-axis. While weight is always down, always in any cases towards the negative y-axis. Suppose I am giving you example. Here is inclined plane. After that, what happens? I put the block here. So where is the weight of block? Weight of the block will always remain towards the y-axis. Not such, it will always be towards the negative y-axis. But where is the normal force? Normal force will be this time here. Because where is the surface of contact? This, then perpendicular to this. But weight is always towards the negative y-axis. So according to this, if we are seeing this situation, then n is equals to mg, w equals to mg. So can n and w, or the normal force and weight, can be called the action-reaction pairs. So can they be called? Since we know mg equals to mg, always mg equals to mg, because since we know that both magnitude are mg, so, or we can also write n is equals to w, because both values mg and mg are the action-reaction pairs. Since the angle between, suppose that the angle between n and w is theta. So theta is equals to what? 180 degree. We can tell in this case theta is 180 degree. They are opposite, equal and opposite forces. Then are they action-reaction pairs? But no, they aren't action-reaction pairs. But why? Now question arises, why they are not action-reaction forces? So here we can reply to this question by giving two rules, by giving two conclusions to this problem. Because the first rule among them, those are two basic rules, means by which if any object, if any two forces are following those two rules, then they are of action-reaction pairs. So first rule among them is, first rule we can call that they should act over two different bodies, and second is the forces should be of same nature. Here we can see it is acting only over one body. Here we have one block, of any certain mass m, but here we are not taking any other body. How it can be? It is not. Second rule, since we know here is w and here is n, they are not of same nature. They should be both of same nature. If any external forces, second will be also external force, if we are talking about action-reaction pairs. If not, it means they are not action-reaction pairs. Done. Now here we can see, since here is n and here is w, so those are not action-reaction pairs. But if we give example of action-reaction pairs, then what is the example? I can give you example such as, suppose that the same block is put over the surface. After that, suppose that the here normal force NA, suppose it is NA. Why NA? We have to differentiate. Of course, we have to differentiate between two normal forces. If up is NA, then down will be also NB. Why NB? Because of course, since we know that this NA means the normal force, the ground will apply the normal force over the block to just put it upward, and the block, it will try to push the ground, or the surface downward. So one will apply NA force and one will apply NB force. Since N is equals to what? Mg. So NA is always equals to NB. Then the particle is stable. Otherwise the particle wouldn't be stable. Otherwise the block wouldn't be stable. So NA is equals to NB. After that we see that the angle here is 180 degree. Okay, those two important rules. But here also it was same. But here we can see that here is also a normal force and here is also a normal force. Both are normal contact force. So first rule it is following. After that what happens? It is following, since we know that both forces are applied over two different bodies. One is the ground. Which two different bodies? One body we have taken as the block and the second body we have taken as the surface. Means the surface of the earth, or the two bodies are the block and the earth. That's why we have taken NA is equals to NB, theta equals to 180 degree. Those two rules are followed. Latter of same nature the forces are, and on two different bodies they are acting. Hence this case is known as the action reaction pairs. So we can write here action reaction pairs. Okay, so this case is action reaction pairs, while this case we have taken, this is not an example of action reaction pairs. So this is mainly the third law of motion, Newton's third law of motion. Now already we have discussed it. So if we want, now we can discuss over the Lami's theorem. And before going to Lami's theorem, first of all let me again rub the board. Okay, done. Now let's move to our new point, that is Lami's theorem. Really it is very interesting theorem. Okay, Lami's theorem. So here what actually is Lami's theorem? Lami's theorem mainly states that just like up to now we have been dealing with two kinds of forces. Two forces acting over a body. Okay, mainly one force or two force. But now Lami's theorem mainly states about three forces. Just like I can give you example. Suppose I have any block here. Okay, suppose later what I do, that from here I apply any external force over the block. Here suppose it is F1. Okay, done, no problem. And after that what I do, from here also I apply an external force F2. Okay, that is also not any big problem. But later what problem is that from here also I apply any external force F3. This is the case that from here we are applying F1, then F2, and from down F3. So three forces are acting over the block. Over one block three forces are acting. So what is actually, so suppose that this angle we have, this angle is theta 1. Later what we can see, this angle is theta 2 and this angle is theta 3. If this is the case, here is F1, then the theta 1. Okay, F2, theta 2, F3, theta 3. This is the case. Then Lami's theorem mainly states that if we have such a case, so those F1, F2 and F3 they mainly describe the sides of a triangle. They are mainly based over the sides of a triangle. They describe the sides of a triangle. That's why they should also follow the sine rule. And what sine rule? Then according to sine rule, if they are just following the sine rule, so according to the sine rule, this may be possible that F1 is equals by sine theta 1 is equals to what? Is equals to F2 by sine theta 2 is equals to F3 by sine theta 3. This is known as the Lami's theorem. Okay, this is mainly the Lami's theorem. If three forces are acting, F1, F2 and F3, then just here we can take theta 1, theta 2 and theta 3. Then F1 by sine theta 1 is equals to F2 by sine theta 2 is equals to F3 by sine theta 3, because those mainly describe the sides of a triangle, and if they are describing the sides of a triangle, it means they will also follow the sine rule, and according to sine rule, then this will be the possible law met for them. So this is really very important and interesting and nice equation. If suppose I am telling that then according to this, if we want F2 by sine theta 2 is equals to what? Is equals to F3 by sine theta 3. Okay, and anyone asks me what is the value of theta 3, and he gives me value of F2, F3 and sine theta, and he gives me value of theta 2. So instantly by doing sine of theta 2, F2 by sine theta 2 is equals to F3 by sine theta 3. In this first of all cross multiplication, later this F will be transferred here. So according to this, sine of angle theta 3, I can write sine of Sine of angle theta 3 is equals to what? First of all, cross multiplication. Sine of angle theta 2 times what? Times f3. Okay, done. Now this will be transferred here, so divided by f2. This is, so from here I can find out the sine of angle theta 3, or the angle theta 3 itself is equals to what? Is equals to the sine inverse of f3 sine theta 2 divided by the f2. So from here I can solve any problem. So very nicely and very easily using this formula or the Lam's theorem, we can easily solve such problems in which generally there are three kinds of forces acting over a single body. So this is known as the Lam's theorem. So this was mainly my today's topic based over the first, second and third law of motion, momentum and inertia, and mainly over the Lam's theorem. So this was my today's topic. Hope you all enjoy. Thank you everybody.